So find the coordinates and nature of any turning point. So I'm going to work with the quadratic here. So negative x squared minus 6x plus 4. So if you think of your knowledge of graphs, we already know a little bit of something about this graph. For one thing, we know that it's a quadratic. So a quadratic has the graph of a parabola, which means it's going to either open down, give us a minimum, or it's going to open up and give us a maximum. Now, if you really pay attention and you remember, if we have a negative leading term on our squared value, then that means that we're opening down. So I should get a graph like this, but we're going to try to find the coordinates and the nature of this turning point. So we're going to find the coordinates of our max and prove that it is in fact a max. So this is just another way of looking at it. So we already know a little bit about this. Like I said, we know that this is a parabola, and we know it's opening down because of this negative. But we're going to use differential calculus to prove that there's a turning point, find the coordinate of that turning point, and then show that it is in fact a maximum. So whenever we're looking for coordinates of a turning point, you always start with finding the derivative. Because at this point in our graph, our derivative is 0. We have no slope. So the derivative of this point, dy dx, is going to equal negative 2x minus 6. And like I said, at any turning point, our derivative is always equal to 0. So we're going to take this and we're going to set it equal to 0. So we need to solve for what x is. So we're going to add 6 to both sides. And we're going to divide both sides by negative 2. So we know that the x part of our coordinate is negative 3, but now we need to find the y. Whenever you're trying to find a y value to go with an x value, you always go back to your original equation. So to find y, then you go negative 3 squared minus 6 times negative 3 plus 4. So we're going to have y equals negative 9 plus 18 plus 4. That's going to be 9 plus 4 equals 13. So now we have the coordinate of our turning point. So we have our turning point at negative 3, 13. And like I said, we can assume that it's a max because we know a little bit something about quadratics, but we're going to prove using our first derivative test that it is in fact a max. So to show that it's max, what we need to do is we need to show that before and after this x value of negative 3, we need to show our slopes were positive before and our slopes turned to negative after. So we're going to set up a sign diagram. So I always set up my sign diagrams on a number line. So we're going to have a number line here with our x value. And here our slope is 0. So to show that it's a max, I need to prove that my slope over here is positive, because we want it to increase first. And then it's negative over here. So we're going to choose test point. So I need any value that is less than negative 3. So let's say negative 5. So to show the slope over here is positive, I'm going to put this into my derivative and show that it gives me a positive answer. Minus 6, so this is going to be 10 minus 6. I don't necessarily care what the number is, I just care that this is in fact a positive value. So that means before negative 3, my graph was increasing. Now we're going to put in any value that is now greater than negative 3. If you can, always use 0. 0 is a nice number to work with. Again, because we're talking about slope, we want to put it into our derivative function. So we're going to go negative 2 times 0 minus 6. Well, 0 minus 6 is in fact going to give me a negative answer. Negative answers tell me that I am decreasing after this point. So if I was increasing, then decided to turn around and start decreasing, this is in fact a maximum point. So we found our coordinate right here, and we found the nature right here. And that's all there is to it, to finding the coordinate and the nature of any turning points. When you're dealing with cubic functions sometimes have two turning points. So sometimes you have to have a third test point over here. But you can watch my other video to see how to complete a cubic function in this type of question.